We on Earth have access to a variety of heavy elements for us to use and take advantage of, some of which are in the phone that I'm recording and in the air I'm breathing. However, these heavy elements are with us because of something very special and destructive, supernovae. Now, before we get into what a supernova is and what their impacts can be, I would appreciate when you like the video, subscribe to the channel, and hit the notification bell to tune for future content. Okay, so what is a supernova? Well, it is the culmination of the life of a very massive star. The lower limit is about 8 times the mass of the Sun. These stars start their lives as hot, blue balls of gas and live this way for several million years. During this time, they fuse hydrogen into helium like any other star, so this is their main sequence phase. Once the main sequence phase ends, the star balloons into humongous red supergiant, some of which have radiuses bigger than Jupiter's orbit, which for reference is several hundred million miles. Once here, the star begins fusing helium into carbon and oxygen, much like our Sun will when it reaches the end of its life. However, it's when this helium fusing period ends that things start to get weird. The star can take one of a few complex evolutionary paths: stay as a red supergiant until death, shrink back into a big blue star, or evolve into a Wolf-Rayet star, one of the hottest and most luminous types of stars in the universe, all depending on the star's mass. Also at this point, the star generally only has a few thousand years left before it goes kaboom. During this time, it will fuse carbon into neon, neon into oxygen, oxygen into silicon, and silicon into iron, all in progressively smaller timescales. In fact, it's theorized that a star fuses all of its silicon into iron in a single day. At the same time, there are shells around the core where less advanced stages of fusion are happening. Finally, the core is 100% iron, and it can't fuse into anything else. With no outward pressure keeping the star's outer layers up, the star collapses at 1/4 the speed of light. Then, when the outer layers hit the core, they explosively bounce off of it. The result is a supernova, the biggest and hottest explosion in the universe. Now, what are the after effects of such an explosion? Well, many things, but first, let's talk about what happens to the star itself. If the star is between 8 and 20 times the mass of the Sun, it'll become a neutron star, a ball of densely packed neutrons that contains more mass than the Sun into a size of a small city. If it's over 20 times the mass of the Sun, it'll become a black hole, something whose gravity is so strong, not even light can escape it. What about outside the star? Well, as I alluded to earlier, all of those heavy elements scatter across the cosmos, creating more stars and planets, and the cycle goes on. On a less positive note, the supernova is so hot that anything within 50 light years of an exploding star would get absolutely cooked. Thankfully, there are no immediately exploding stars within that radius of us. The closest well-known red supergiant is Betelgeuse, and even that is over 600 light years away, and two, probably won't explode for hundreds of thousands of years. When it does explode, though, it could be visible in daylight for literally months. And that concludes this video about exploding stars. As always, I would appreciate one like the video, subscribe to the channel, and hit the notification bell to tune for future content. Thanks and have a great day.